Hi, morning everyone. We've been working with exponents and we talked about what to do when we're multiplying exponents and we're taking the product of exponents. So let's look at some examples that we've covered already for exponents. So we've covered something called multiplying exponents, or the fancy word is product of powers. So the word product means multiplying. So we covered something called product of powers. And this has to do with if I say 3 squared times 3 to the 5th. Okay? And if you could break this down in your head, if you forget, I mean, we don't do this like every day. We barely even do it sometimes every week. But when you do see it, you want to make sure you get it right every single time. And the trick is to ask yourself, what is 3 squared really? Isn't that just 3 times 3? And 3 to the 5th is 3 times 3 times 3 times 3 times 3. And since we're multiplying all together, hey look, we're just multiplying everybody together. So how many 3's do we have total? We have 3 to the 8. That's like the most basic way of trying to understand, wrapping our heads around this. But we want to get away from just having to write 3's all the freaking time. So we have a rule. If I'm multiplying powers, we actually add the exponents. 2 plus 5 is, whoops, sorry, I misadded there. This is a 7. 2 plus 5, 3 is 7. We can generalize this, meaning I could just use variables instead. If I say 3 to the a power times 3 to the b power, it's always going to be answered 3 to the a plus b. So whenever we're multiplying powers together, we just add the exponents up, because I'm just adding another crew of multiplying numbers. Now remember, the idea of exponents is just a fast way of writing multiplication. Right? I don't have to write 3 times 3 times 3 1,000 times. I can just write it as exponent. So if we see a problem that says 3 to the 10 times 3 to the 11, well, we can just add them. 3 to the 10 plus 11. You can hopefully see that I actually have 21 3's. Now, I don't want you to actually calculate that. That's probably a huge number, going to break your calculator. But on your calculator, you could easily type the number 3, and then there's usually a button that looks like A, B, and then you type 21 on your calculator. If you have a nicer, more advanced calculator, sometimes you'll see this little arrow. You go 3, and then you'll see it's called caret. And then it looks like a little arrow going up, and that means kick it up to a superscript, and then you would hit 21, and both these would give you the same answer. I mean, you could also type 3 times 3 times 3 times 3 21 times, but I hope not. Okay, so let's review another thing that we covered last time. And this was called power of powers. Power of powers. That means if I take the exponent of an exponent. So if I say 3 squared to the, let's say, 5th power here. Let's go big. Well, this exponent is taking this whole 3 squared and writing it 5 times. So let's do that right now for our example here. It's 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. And I wrote it 1, 2, 3, 4, 5 times. Well, how many 3's do we have total then? Well, isn't this 3 times 3? And 3 times 3? And 3 times 3? And 3 times 3? And 3 times 3? Oh my goodness, we're multiplying them all together. How many 3's do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see we have 10 3's all together. Now, hopefully you might see the pattern here. When I'm taking the power of powers, we don't have to write it all out. The rule is simply just multiply the exponents together. We're not adding them, we're multiplying them. So that's 3 to the 10th power. Why are we multiplying? Because remember, multiplying is a fast way of addition. And since I'm multiplying here, I'm adding, which would have given us 3 to the 10th power. We could have wrote this as 2 plus 2 plus 2 plus 2 plus 2. We could have wrote that following our previous rule. Because when I'm multiplying powers, we add the exponents. And when we're multiplying, we're adding quickly. So it's easier for us to just multiply them. So the general rule here is if I'm saying 3 to the a power to the b power, right, an exponent of an exponent. Well, this is more advanced than me multiplying powers. Well, we multiply exponents here. 3 to the a times b. These are our two main rules. Like, what do you do when you see powers and exponents with each other? Like, what do you do? Okay, so today we're going to learn a new way of looking at exponents, and that's negative exponents. Let's jump down to the bottom. Let's look at negative exponents. Negative exponents here. And here's the easy idea here. If I wrote 3 squared, we know that's 3 times 3, right? But if I write the negative exponent, 3 to the negative 2, this is actually, why is it a negative? And it's actually us rewriting this problem as 1 over 3 squared. So what I'm saying here is if we have a negative exponent, it means you don't belong on this side of the road. You actually belong on the other side. And this is the same as me writing 1 over 3 times 3, which is 1 over 9. Okay, so we're going to do a couple examples of this, of negative exponents. So if I write 3 to the, let's use a different number than 3 now. Let's use 4 to the negative 2 power here. We said negative exponent means you don't really belong here. You're from the other side of the denominator, of the numerator denominator. So if you're on the numerator, you go down 1 over 4 squared. But then why do we even have negative exponents? Like, it's because maybe you don't want to write things as a fraction. And I can rewrite this as, bring this to the top. So we would write this as 4 to negative 2 power, and it's no longer written as a fraction. It's just another way of writing fractions now. If I write 1 over 25, we can write this as 25 to negative 1 power. We can bring it to the top. And if you want, we can rewrite this as 5 squared. Isn't 25 really 5 squared? And this is a reminder, what do we do with power of powers? What do we do with power of powers? Do we add or multiply these numbers together? We're going to multiply them. So 2 times negative 1 is negative 2. Now let's see, couldn't I have gone the same way by saying 25 is 5 squared? And if we don't want to write on the denominator, we can always write on top. Get to the top, negative 2. You don't belong here. You don't belong on this side of the streets. So many of us are from immigrant families. I'm from an immigrant family. And have you guys ever visited your parents' home country? And when you visit there, everyone can tell you're not from around here. Like, oh, you're from America. And when I went to Taiwan, that's like the sentiment. Like, they're like, oh, you're from America, aren't you? And they can tell by something about the way you walk or the way you talk or what you wear that you're not from around here. And that's kind of this badge here. This negative exponent means you're not from this side of the street. You're from the other side. So, again, we can always rewrite this as, hey, you're not from around here? Fine. Get back to your side of the street. Now, when I move it back to the other side, of the fraction, we can remove that tag, that negative sign, and we can bring us back to our problem. Okay, so in your homework, they're going to ask you to write the expression as a whole number with a negative exponent. Don't evaluate it. I don't need you to multiply it out. I just need you to rewrite it. Okay, so let's look at another example here. If I say 1 over 10 squared, I don't want you to write this as a fraction. I want you to write this as a negative exponent. Okay, so you don't belong here, so we're going to kick you on top. And let's say we're going to write 10 to the negative 2 power over 1. Do we really have to write that over 1? No, you don't even need to show that in the work. It's just negative 2 power. You don't belong here. The base and the exponent do not change, right? The base is still going to be 10. The exponent is still going to be 2. Only thing that changes is that exponent becomes a negative exponent. That's this easy skill. If I write another example, 1 over 321 to the 5th power. If I don't want to write this on the denominator, I want to write this up on top. No more fractions. I don't like fractions. F fractions. We can say 321 to the 5th power, but to denote that you're not really a top number, we give yourself a pass, a negative sign. If you guys ever visit your parents' workplace, sometimes they're very fancy with security, and they'll make you wear a pass that says visitor, right? Or if you've gone on a field trip before and they make you wear a thing that says, again, visitor, you're not an employee here. Whenever I go to the main district office, they'll make me wear a pass around my neck that says visitor. And this idea of this little negative symbol, you're a visitor up here. And that's it. So half your homework is you just changing the signs. What if the problem says, hey, you're given a negative, I want you to write this without the negative. Okay, where does the negative go? You go right back to the bottom. Do not forget the exponent. So to feel comfortable about going back and forth, okay, hopefully that feels pretty easy for you guys. And this goes for any, if I use a letter instead, 1 over b to the 5th power. If I want to write this without a fraction, we would kick it to the top. So it would be b to the 5th power, but because you're now on top, we give you a little negative sign in the exponent to say, hey, you're not from around here anymore. And this is not just a negative 5 as a symbol, it really means negative 5 as an exponent. It's that simple, folks. Now, the thing is, will you remember it? Now, the next skill here is, let's write a couple of values here that are a positive and negative. So, here's some skills. And if I write this, b to the negative 2 power over b to the 3rd power, I want you to rewrite this where everyone's a positive exponent first. We're going to move stuff around. So, who doesn't belong? Who's on the wrong side of the street? Who's a stranger in my neighborhood? Take a look here. The guy with a negative exponent. So let's rewrite this. Let's kick him back. Hey, you don't belong here. Let's kick you back down. So it'll be invisible 1 over, because fractions always need that invisible 1, b cubed times b squared. If you take a look here, I moved it to the bottom, and we're just writing our values next to each other. You might not be sure why. Let me rewrite this as 2 different problems. This is on the side. You don't need to do this. This is actually a waste of time. But if I write b negative 2 over b cubed, this is really b to the negative 2 power times 1 over b cubed. Just in case you need to see why this is true, b to the negative 2 power is actually 1 over b squared times 1 over b cubed. And if we're looking at fractions, the top times the top and the bottom times the bottom, if you want to look at another way of looking at this. Now, we're back to what we did last time in class. What do I do right here? since I'm multiplying powers, what do I do to the exponents? Do we end up with b to the 5 or b to the 6? Okay, will this be b to the 5 and b to the 6? Those are two different numbers. And since we are multiplying, we say we add exponents. So it's 1 over b to the 3 plus 2. We're adding exponents. This becomes 1b to the 5. Now, I'm showing a lot of work here, but in actuality, you can just jump from here to here, and that's perfectly fine. I would always show this as work, and then you can jump from b cubed times b squared to b to the 5th. Okay, let's do another problem like this. If I say, another example, let's say x to the negative 10 over x to the, let's say, 7th power, okay? Let's rewrite this so there are no more negatives. So let's get rid of the negatives first. That'll be 1 over, this 10 goes down, x to the 7 times x to the 10th. As a reminder, what am I doing when I'm multiplying powers? Do I add or multiply the exponent? Do we end up with 10 to the 70 or do we end up with 10 to the 17? Remind yourself that. Which one is it? If you're not sure, let me go back to the fundamentals. This is 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many 10 x's do we have total? If they're all multiplying each other, we have a total of 17. So this is really just us learning how to combine exponents. We've learned how to combine variables before. If they're like terms, we can add them. But now we're multiplying powers, multiplying exponents. Okay. Let's do one last one. If I write a to the 3rd power over a to the negative 2 power b cubed. Okay, we have a couple things going on here. So who gets moved? Who gets moved? Remember, our first goal is to write things without the negative exponents. It makes our lives a lot easier. So the only person that gets moved here is the a cubed, the b cubed, or the a to the negative 2 power. Our only person that's a little weird, a little standing out here is our a to the negative 2 power. Let's rewrite this. You go on top, a cubed times a to the 2nd power. Please don't bring in the negative. Okay, don't bring in the negative. You've retreated your negative away to come back home. Now you're with family. And then we can just combine what we can. I have a cubed times a squared is a to the 5th power over b cubed. And you can't do anything with this because a's and b's are different. Okay. So let's do one more problem here. I want you guys to try this. I'll give you guys a moment to do it. I'm going to use 3 squared times 5 to the negative 2 power over 3 to the negative 4 times 5 cubed. Can you first step rewrite everything so you put so everyone has a positive exponents. So first, right now, you guys go ahead and do this. I'll give you guys a couple seconds to do this. Rewrite this problem so that everyone's on the correct side. You're going to be moving a couple numbers, and that's okay. I see a negative. I see a negative. So you guys don't belong here. So let's allow you to move back to where you're supposed to. I feel like a kindergarten class. Not you guys, I meant like moving these numbers around. Everyone go back to their groups. Everyone go back to the original table. Okay, hopefully you guys are able to move them around. We have 3 squared, that doesn't change. We're going to move up the 3 to the 4th. We have 3 to the 4th now. On the bottom, we have 5 cubed. and then we're adding a 5 squared to it. Okay, now we can combine it. 3 squared and 3 to the 4th. We're combining our exponents. We have 3 to the how many? Is it 8 or 6? 8 or 6? Hopefully you'll notice that we say 2 plus 4 is 6. And on the bottom, we have 3 and 2. Since we have the same base, we can combine them to be 3 to the 5. Sorry, 5 to the 5. Okay, this is just another way for us to deal with numbers. We're learning a lot of skills. Every day we learn a couple more skills. Okay, so now here is our next skill today. And the next skill is about dividing fractions. Wait, dividing fractions, the same thing. So dividing exponents. And this pretty much looks like fractions, like what we've been doing already. So the idea here is I'm going to give you any type of exponent, and we're going to see how do these exponents combine. So let's do something easy. Let's do 2 squared over 2 cubed. How do these divide? Now, our old classic way of doing this is you would just say what's 2 times 2. And this is slow, okay? I'm going to write this a slow way. We're going to say 2 times 2 is 4, and 2 times 2 times 2 is 8. And then you would divide these. Doesn't 4 go into 8 2 times? Right, that's how we would divide it, the old classic way. Now, I'm going to do this our kind of advanced way here. Now, I'm going to do this I'm going to do this a couple different ways. Now, here is the slow way. We have 2 2's on top, and we have 3 2's on bottom. Now, what's 2 divided by 2? What's 2 divided by 2? That's 1. What's 2 divided by 2? That's 1. And what are we left over? We're left with 1 2 left over, but on the bottom. Gives us our same answer, doesn't it? Okay, so this is our classic way of doing it. We just start canceling out the 2's because 2 divided by 2, it doesn't become 0, it becomes 1. So we're left with a bunch of 1's. This is really becoming like over here. It's 1 times 1 times 1/2, which is really just 1/2. Okay, so when you're dividing the same number, when it comes to exponents, we're just canceling out numbers. Let me give you just another one on the side. I'm just write this really small so you guys can see it. I mean, so you guys can like try it. If I say 5 cubed over 5 squared, isn't that just 5 times 5 times 5 over 5 times 5? And we can divide them. 5 divided by 5, 5 divided by 5, and we're left over 5. Now, we don't want to do this for a huge number. What if I wrote 5 to the 10 power? What if I wrote 5 to the 100 power? We don't want to write out 100 of these. So let's look at what the skill is. And there's a couple ways that we're going to use the skills that we learned before to redo this problem. So let's rewrite this problem here as 2 squared over 2 cubed. The simplest way is what we just did. It's just to say, hey, I have 2 and 2, we have left over 1. Okay? But I'm going to do this in another way to say, hey, if we're dividing powers, we are actually subtracting powers. Take a look at that. If I am dividing powers, we are subtracting exponents. Okay, dividing. Oops. I should rewrite that. Dividing means subtracting. Dividing means subtracting exponents. How do we come up with that? Well, didn't we say multiplying means adding? Didn't we say 2 squared times 2 cubed? If we're multiplying powers, we are adding exponents. So if multiplying is adding, then dividing must be subtracting. And that's actually true here in this case. If I'm multiplying powers, we add exponents. If I'm dividing powers, we are actually subtracting exponents. And who do we subtract? We always subtract the denominator. We always subtract the denominator. And this gives us 2 to the 2 minus 3 is, that's negative 1, so we're negative 1. And we can rewrite this as 1 over 2. The same answer as we did before, but a little bit more complicated, but we can rewrite that. So what if I write 5 to the 3 power divided by 5 squared? We said if we are dividing powers, the rule is that we are subtracting exponents. 5, 3 minus 2. 3 minus 2 is 1. So we're just left with the number 5. Let's do a couple more examples of these. If I say 6 to the 7th power divided by 6 to the 3rd power, how would I rewrite this? As 6 to the what on top? Okay, I want you guys to try figuring that out. If I write 10 to the 11th power over 10 to the 20 power, what am I writing here? This is 10 to the what power? Okay, so if I'm multiplying, we're adding exponents. So if I'm dividing, I'm subtracting exponents. So in my first one, hopefully you guys have caught it already. It's what minus what? Is it 7 minus 3 or is it 3 minus 7? And the rule is it's top minus bottom. Okay, so it's 7 minus 3. Over here it's 11 minus 20. So our answer is 6 to the 4th power. And over here, it's 10 to the negative 9 power. And the cool thing on IXL, you can write it as a fraction form or you can write it as an exponent. So just make sure you read the directions because every problem might be different. It says, express your answer as a positive exponent. Sure, if I'm expressing it as a positive exponent, we are done here. But if I'm asked to express this as a positive exponent, well, negative 9 is not a positive exponent. So we have to rewrite it as 10 to the positive 9 on bottom because you got to get back on your side of the street. Now, you could have, and this is of course the extreme slow way, and this is not the skill, but if I write 10, 10, 10, if I write this 11 times, right, 11 times, and I write this 20 times, they would have canceled out all the way, leaving me 9 extra on the bottom. And you can kind of see that. Hopefully you can see that 20 cancels out with 11, leaving 9. But where are they? Are they on top or bottom? They are on bottom. Okay. Now, I have one more thing. Just as a side note, here's advanced skill. The advanced skill is to say this, using the rule, every rule that we've talked about. If I write 6 to the 7th power over 6 to the 3rd power, we can say, you know what? I'm going to rewrite this so they're all on top. They're all on the same side. So that means 6 to the 7 times 6 to the negative 3 power. Are you guys okay with how I wrote this on top as a negative exponent? Now we change this dividing into a multiplication problem. So what do we do with multiplication problems? We add exponents. This is 6 to the 7 minus 3, which is where we get dividing is really subtracting. Dividing is really subtracting. Sure, it's a rule that we kind of made up in a sense, but it also flows from everything that we learned already. Numbers on the denominator can be written on top as a negative exponent, and now since we're multiplying, we're actually subtracting from the top value. If I wrote 10 to the 11th power over 10 to the 20th power, this can be really written as 10 to the 11th times 10 to the, what type of 20 is that? Since I'm going to move it on top, it's become a negative 20. And since we're multiplying powers, we are adding exponents. So 10 to the 11 minus 20, which is exactly what we said here, is really subtracting our powers. subtracting our exponents. Okay. So these are the skills that you guys will be demonstrating on your homework. So let's jump to your homework real quick, and just so we can be on the same page. And let's do V5 here. V5 for Algebra 1. Uh-oh. Oh, darn it. Give me a second. Okay, so this one here, let's take a look. Simplify the expressing using only positive exponents. So what happens to the problem? Let's go ahead and write on this. We're going to say q squared over q to the negative 4. We are subtracting because we are dividing. So there's a couple ways of doing this. We can say, hey, since we're dividing, we might as well just subtract it. Negative 2 minus negative 4. Okay, take a look here. I just wrote it with a minus sign. Negative, negative become a positive. This is really q to the 2 plus 4, which is q, to the 6th power. But if I want to actually do this a different way, not using the rule, what do we do with negative exponents? Does the negative 4 really belong on the bottom? It really belongs on the top. Q squared times q to the 4th, because I moved it to the top. And we can say, well, it's just really q2 plus 4, which is also q to the 6th. So both these rules, whether we go the long way using all our rules about moving negative exponents around, or us using division is subtraction, both yield the same answer. Now, our answer is q6, q to the 6th power. Let's go ahead and write that. I'm going to type the letter q. It's going to be q exponent, and make sure you use that exponent that they have, q6. Okay. What if they're both negative? Well, what if they're both negative? I see a negative 2 and negative 8 here. Well, we follow our rules. The rules have not changed. This is, we can say n, if I'm using the subtraction rule, if I'm dividing, I'm subtracting. Negative 2 minus negative 8. This gives us n, negative 2 plus 8, because negative negative become positive. That gives me n to the 6th power. If we go the other way, same exact idea is going to happen. N to the negative 2 power. We write it on top. N becomes a positive 8. And doesn't negative 2 plus 8 become n to the 6th? Okay, they want us to write it as a positive exponent. Okay, so both ways are totally valid, whether you want to say dividing is subtraction, or we can write everything as write everything on top. Okay, here's n to the 6th. Make sure you're using the right variable here. Superb. Now, for this problem here, again, there's a lot of different ways for us to be doing these problems. There's a lot. We can say y times y over y times y times y also. That's a very classic way of looking at it. And if they divide, bam, bam, we still have a y on the bottom. But let's practice our other skills here also. If I say subtraction, dividing a subtraction is y squared minus 3. That's all you have to write. If I'm dividing, I'm subtracting the exponents. This is y to the negative 1. Now, if I wrote y to the negative 1, IXL will do its thing and it'll mark me wrong, because IXL likes doing that. But it's because my directions say write it as a positive exponent. What is a positive exponent? It means you don't belong here. You don't belong here. You need to go back to where you're positive. Okay, let's write that. So I'm going to type it as a fraction, 1 on top, and the letter y on bottom. 1 over y. Okay, there's a lot of different ways of doing this. Let me do it one more time. This one has both negatives. I'm going to show you guys. Again, a lot of different ways. They're all right. They're all right. But we need to know them all. So if I want to, hey, negatives, I don't like negatives, I don't like negatives. This is q to the 7 and q to the fourth. And that's actually one thing that we should do sometimes. Just move everyone to the positive side. Move everyone to the respective positive side. Now I have q. Let's write it out. Q, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Right? Doing this takes a long time. But if it's helpful for you to see that 4 of these cancel out, leaving me only 3 left on top, great. That's a great skill. But I want to also advise you that we could also, from here, have said, if we're dividing, aren't we just subtracting? Q7 minus 4 is Q3. We could actually have done it back here. Q to the negative 4 minus negative 7. Negative negative is a positive. Q negative 4 plus 7. Negative 4 plus 7 is positive 3. There's all these different ways to get to that same answer. Right? We can spin them so they're positive and then start canceling them out. We could just take it as it is and just subtract our exponents. Leaving me 3 positive, and that means they're on top. If it's negative, that means it will still have been on the bottom. Now, I'm gonna go ahead and jump to the last section here, where it gives us a lot of different numbers. No, not this one. Nope. Not the one I'm looking for. Oh, it's giving me the same ones over again. I'm just going to enter something wrong. Wait, and then it'll give me another one. Yeah. I want to show you guys a specific type of problem. Okay, this is a good one. This is what I'm looking for. So you have 2 different variables. Some are on top, some are on bottom. Here is the easiest method that I want kids to be able to do. Okay, easiest method. Here we go. Easiest method is to see how these guys are negative. Move them to where they would be positive. So if I rewrite this, this would be p cubed, right? That hasn't changed. Right? P cubed hasn't changed. But then we're going to move up the negative one to become positive. Divided by the q squared that from the bottom, right? Q squared from the bottom hasn't changed. But the 8 is going to come down because that's a negative. Q8. Now once you have rewritten this so they're all positive, we can now combine them. These p's are like terms. Let's go ahead and combine those. How many p's do we have total on top? 3 and 3 make 6. On bottom, I see on bottom we have, these are both q's, right? Q2 and Q8 add up to Q10. And that's it. We're done. We can't simplify anymore. Okay. So whenever you have multiple variables, the goal is to make them all positive first so our brains aren't as confused, and then you can go ahead and start combining them or canceling them. All right. We'll see more of the advanced problems of these next time, but this is kind of like the basic starting point. Okay. Thank you very much.